Okay, so 6.2, integrating using substitution, and then on the back, separable differentiable equations. This is actually called separable variables usually, and then I wrote that on the back with you guys. Okay, so number one, we did all of this together, so I'm just going to review this one if you need it, and then number 2 and 3 are new, right? So number one, okay, so the first step is, let's try this in box method. Let's see what happens. So if we use box method, which is big brother, then we think, okay, well, this has more going on, and then what's the antiderivative of something squared? The antiderivative of something squared is something cubed, and then we have that box in front. So our next step is to take the derivative of this, set it equal to the original. So I take the derivative, the 3 comes forward, and then you have box times blah, 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 squared, times the derivative of the inside. Okay, and then notice there's a 2 here, but I'm gonna just like block it off for a second, okay? Set that equal to the original right there. And then now we can cross this off, cross this off. This is an x plus 1. This is actually 2 times x plus 1. So that's why I crossed that out and put a 2 here, okay? And then we solve for the box equals 1/6. All right, we have our final answer for box method or big brother method. All right, how is substitution different? So substitution is different by, literally we're like substituting, okay? Instead of thinking about what's the big thing that's happening and then let's go backwards using a box, now we're thinking, okay, if we look at this, what's something that I can just replace and it would look easier? Well, if I know it seems kind of crazy in the beginning, but if I replace all of this, if this is called like u, then it'd be u squared. If I could get that to say u squared, then the antiderivative of u squared is 1/3 u cubed. I could do that in my head. Okay, so let's try that. And what you try might not always work, and that's the problem with substitution. So for substitution, you're going to start with, what do you want to substitute? So let u equal, remember this is called u sub, right? In a lot of times in a lot of books and stuff. So u sub, you usually let u equal something. So let u equal the stuff inside. And then the very next step is going to be, okay, now find the derivative. So the derivative of u is du over dx. So this is du. And then instead of over dx, I put the dx on the other side. Okay, you'll see why in a second. So I look at this and I look at this and I don't see what I want to see. I want to see x plus 1, but this says 2x plus 2. So I have to factor out the 2, and I really want this part of it. So I have to take that 2 and divide it to the other side. And now this is all by itself. I really want this part and I want this part. So what I do is now I substitute. So instead of that whole big quantity, I can now write u. And then instead of dx, I can, or sorry, instead of what, all of this, which is underlined here, I can write 1/2 du. And then I'm going to take my 1/2, factor it out to the front. So if it's a, constant, you take the antiderivative, you leave it. You can put it in here if you want, it doesn't matter. And then if you take that out in the front, then you realize that's a 1/2, and then this becomes 1/3 x, or I wrote x, but really it's u. Let me fix that. Okay, u cubed, right? So the antiderivative of u squared is 1/3 u cubed plus c. And then now I multiply, and when I multiply, I get a 1/6. When I multiply this, I do not get half of c, because half of a random constant is still a random constant. And then this seems like a final answer, but, oh, dude, I forgot, see? I fixed the other one, I didn't fix this one. Okay, so that's a u, that's a u, that's a u. Okay, is this a final answer? This is not a final answer because I wanted to find the antiderivative with x's. So now I just take this and I just replace the u with all of those x's, and then I have the same answer as before. So it's just another way of finding an antiderivative. Okay, so for number 2, you're going to do the box method or big brother method, and that's going to be the first one. So if you do big brother method or box method, you're going to get some answer. So do it yourself and then check your work. And you get this, right? So we say, okay, this is a power of 4. Going backwards, it used to be a power of 5. Take the derivative, you get this. set it equal to the original, you get this, cross, 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 box equals 1/5. Okay, so this is the box method. And then substitution, we started this together, let u equal, and then you guessed sine of x. So if you guessed the wrong thing, it's not because you're wrong and you're bad. It's because sometimes, you got to try different things. But for this one, the sine of x will work because what is the derivative? Du equals cosine of x dx. Okay, but notice this and this, that's what we want, right? We want a sine of x and we want a cosine of x dx. So now we have everything we need. So now we know our substitution will work. We substitute and we get that. And then we take the antiderivative, we get 1/5. And this is a u, so we plug back in the sine of x, and that's our final answer. That's it. So you can see this is, if you do the box method fully, and you need to think about it fully, then this is much faster, right? So it just depends on the problem. Okay, so I do want you to try this using substitution. If you try this using substitution, I honestly do want you to try it. Do it now. Pause. And then I want you to fail. And sometimes, the reason why I want you to fail is because I would assume that for this problem, you would say, let u equal cosine of 2x. And then you would do your stuff, and then it wouldn't work out. Like, you won't be able to substitute things. So instead, for this one, I'm going to let u equal, so I'm going to change it to secant, right? And then I realized that when I change it to secant, well, if I just have secant of something, that's really easy. The antiderivative of secant u is tangent u, or secant squared u is tangent u. So I just need to substitute the 2x. And it seems kind of simple, but we are using substitution. So let u equal 2x, just this part in here. Du would be 2 dx. And then dx, so this would be secant squared u, and I still have the dx. So dx equals, I solve for dx, 1/2 du. So now I can replace, instead of 2x, I have a u. Instead of dx, I have a 1/2 du. And then I can move the 1/2 to the front because I don't really need to use it. I really want to just save it for later. What's the antiderivative? It's just tangent. Okay, now plug back in the 2x, and then you get that as your final answer. Okay, so I just want to show you sometimes it's not that you're wrong, it's not that you did it wrong, it's because some substitutions work very quickly and some don't really work. So you have to think about it and decide on the correct substitution. Okay, your homework, we're not done with the notes, but your homework is not this, so I changed it. It's a little bit shorter. I think it's like every other odd or something. So give that a try, and then also you want to do half box method and half substitution. So if you want to do all substitution, that's fine also, but you're going to practice both, okay, in general. So if you feel really comfortable with box method, then just do all substitution, but you can't do all box method, okay? You have to do at least half substitution. Okay, on the back, we did these two together. So, oh, by the way, if you didn't do this, make sure that you call this separable variables. So that's normally what we call it, and if you look it up, that's what it is. So I don't know, this book just, sometimes, I follow what the book says, and I'm like, wait, that's weird, I never say that. So it's not wrong, but separable variables make sense, because you want to separate the variables, and then you integrate both sides to solve for y. So to solve, you gotta separate, integrate. So first we separated both sides. I mean, I don't know if we really need to go over this again, but the big thing is when you see a dy, I would usually put a 1 in front of there because the antiderivative of 1 in terms of y is y. And then if you don't do that, sometimes you're like, I don't know what's the antiderivative. But if you see a 1 there, it's a lot easier to understand because we know the antiderivative of like 1 in terms of x would be just x, okay? And here I did a constant on both sides. But remember, if you have two constants, you need to write c sub 1 and c sub 2. And then when you subtract a random number from a random number, you get a third random number. So I don't need to put c sub 3 because there's only one c here, so I just leave it c. But for the second problem, we didn't write c sub 1. You guys chose not to. So for this one, you don't have to write c sub 2, you can just write c. And then in the end, again, you still have c. Don't forget that when you're taking the square root, if you're the one taking the square root, you have a plus or minus, okay? That makes a huge difference. That's like missing half of your answers, okay? If it's graphed, you're missing half of the graph. That's huge. Half of $1 million is a lot of money. You don't want to miss half. Okay, so number 4 we did not do together, but number 4 is a way easier version of basically number 6, which we did do together. So number 4, go ahead and separate the variables. This stays here, this gets multiplied, the y goes on the other side, and then, you know, just kind of check your work. I said I normally don't do that, and I normally don't, but this is terrible, don't do this. I don't know why I wrote this. So what you want in the next step, I'm going to say comma, is really you want a 1 over y dy equals e to the x dx. And then you want to integrate both sides. You have to show that step where you're integrating both sides. And then we get to this step. So 1 over y came from ln of absolute value. Again, if you don't have the c sub 1 and you just have a c here, that's fine. And then let's see what you can do. Well, I just wrote it like this. And then this is that step where I was like, how do you get rid of the ln? You do e to the power. And then now you have an absolute value of y equals all of this. So this we talked about before. This is really, should I do it on the next one? No, I'm going to do it here. So this is really e to the x plus c. But remember when we have e to the power of e to the x plus c, so e to the power of e to the x plus c, like this, it's the same as e to the x times e to the c. And what is e to the c? E to the c is c, because a number to the power of a constant is another random constant. So really this, if we were to rewrite it, is c e to the x, because we can just take that and multiply it either way, right? We can write it in front or back, whatever. Okay, so realize this is the same as this, okay? Okay, but in the next step, I rewrote it as this. So it's the same as this, right? But then I got rid of the absolute value and I put a plus or minus. And then I put the c in front, and then I still have a plus or minus. But here's the thing. If you have a positive or negative constant, so this is a random constant, well, the random constant is already random, so it could be positive or negative. So really the final answer should be equals c times e to the power of e to the x. Okay, so this is the final answer. So there you go. Okay, number 5. Number 5, I did a little bit extra work on another sheet of paper, so I'm gonna go like this. So solve using separable variables. All right, so you get the y's on one side and the x's on the other. You do that first. Come on, do it. And then I hope you see something like that. Right? So I would do 1 over to make it easier to see visually, and hopefully you'll recognize this. And then the 2x, and here's your e to the x squared, and then your dx gets multiplied to the right side. Okay, so from here on the left side, what's the antiderivative? Come on, you think about it, take a guess. Don't use Big Brother, that's my hint. Okay, on the right side, if I am not sure what this is when you take the antiderivative, you use Big Brother or whatever method you want, okay? So you can use substitution if you want. But if I use Big Brother, I get to here, so I say, oh, e to the something came from e to the something. But then if I think about it, if you take the derivative of this, don't you get the same thing times 2x? So box equals 1. Okay, so I can do that pretty quickly. I don't have to like fully do the box method. Okay, that means that the left side, when you take the antiderivative, equals e to the x squared plus c. What is this when you take the antiderivative? It is, you gotta recognize it, tangent inverse of y, right? 1 over 1 plus x squared is tangent inverse of x, because 1 over 1 plus box squared is going to be tangent inverse of box, right? So I know it's been a little while. Okay, so we have this. We're solving for y. How do you solve for y? Okay, tangent inverse of this. How do you go the other way? I have to remember. It's just a tangent. So tangent inverse is like, you know, the opposite of tangent, right? So instead of tangent, this was tangent inverse. Now we take the tangent of that. So y equals that. Okay, I said show more work, but I already did that with you over here. All right. Okay, and then the very last one we did together. So if you're all good with that, then we're good. But here is another way to do it. Okay, so I did this a little bit differently than what we did together. They're both correct. Technically, they're both correct. Okay, I need another paper. All right, I'm gonna go like this. So the first part stays the same. So I'm going to go ahead and separate my variables like that. And I'm going to take the antiderivative. When you take the antiderivative, you get an absolute value, ln absolute value. And then again, we usually don't write twice. We just say equals c. Okay, and that's fine. Okay, and then we did, I did it right here. Okay, so in this step, instead of solving for y first, you can actually solve for c first. So once you get to somewhere you're comfortable with and you have a C, if you want, you can just go ahead and plug in now. So that's possible. So if you plug in now, then you get ln of 4 equals, plug in 0, and then you get 0 plus c. So c equals ln of 4. Notice this is a different c than what we have in our notes, but it's going to be okay. It's going to be okay. So now you plug this c back into here, okay? So if I do that, I get this. So if I plug ln of 4 into here, I get that. Now, how do you get rid of the ln? Because we want to solve for y. Now you're going to do power of base e, both sides, sorry. And then I can go ahead and use my log properties, and I get absolute value of y plus 1 equals e to the power of all of that. So I'll rewrite it. I'm going to rewrite this part, actually. This is an absolute value. Oh, that's messy. I hate that. And this is plus or minus. I'm going to have to rewrite this later. So this is plus or minus. This is an absolute value. And then it's being multiplied. So remember we said when it's a plus as an exponent, it's the same as times the same base to that exponent, right? But what do we know about this? Well, this right here is, sorry, I gotta look really quick. This right here, oh, there's a reason I don't have the plus or minus. Jeez. Sorry, I'm not gonna make this video again, but I'll tell you why I don't have a plus or minus and why it's just positive. There's a really good reason for it, why I don't need the plus or minus, why I don't need the absolute value anymore. Because you already know that y is positive. Y is 3. So when x is 0, y is 3, so y is positive. So that's why this is all positive. I don't need the plus or minus. That's a hard thing to realize though, okay? So that's why I forgot. So y plus 1 equals all of that. And then that's the same as if we can do e to the ln of 4, then this is really 4. The 4 can come forward, and then minus 1 from both sides. Man, that is ugly. I don't like that. Okay, anyway, that is the end of the notes. You give the homework a try, okay? There's not a lot of these problems in the homework. I don't know if that's written twice. I don't know why. But there's not a lot of these problems in the homework. So we'll give this more of a try tomorrow, all right, for homework. Okay, but there are like 2, I think. So good luck with that. I'll see you at 2 if you need any help with this.